Okay, so let's take a look at this check for understanding that we had with our projectile motion problems. You should know how you scored because the quizzes app will tell you as such, but I want to work through the problems in case you didn't score well, that you now understand how to do these problems. So let's take a look at number one. All these problems work out the same base information. We've got a ball that's thrown horizontally off a building that's 52 meters high. So it's going to look something like this. We've got a ball and it is being thrown horizontally. That means it is not thrown up or down at all. It is only moving in the x dimension. And there's a typo on that, but it's correct on your version. The velocity of the ball is 18 meters per second. What's the initial velocity of the ball in the x direction? Well, it's 18 minutes per second because all of the velocity is horizontal. If the ball were thrown at an angle, some of its velocity is x and some is y. But when a ball or something is moving horizontally, that means its only dimension of motion, at least initially, is the x. So the x velocity, at least starting off, is 18 minutes per second because that's what we were told. So we go to the same problem. What is the initial velocity in the y direction? Well, it's thrown horizontally, so all the velocity is given in the x. This ball was not thrown up or down at all because it was horizontal, so the initial y velocity is 0. Okay. What's the acceleration of the ball in the x direction? Well, as soon as it leaves the person's hand, there is no way to speed the ball up. Like once the ball leaves your hand, you can't make it go faster or slow it down. There's no engine, there's no brakes. So it has no acceleration in the x direction because there is nothing acting on it in the x direction. So the acceleration is 0 meters per second per second. Now, what's the acceleration in the y? Now, the y is different because as soon as you throw the ball, as soon as it leaves your hand, gravity starts to pull it this way. And gravity will cause an acceleration. And that acceleration that we know is due to gravity is negative 9.81 meters per second per second. So, how long does it take the ball to hit the ground? The ball moving this way, we kind of get what's happening here. It's going to go something like this and strike the ground. Well, we want to know the how long is the time. So we need some kind of kinematic formula that will work in the y dimension that will allow us to solve for time. Well, what else do we know about the y dimension? We know that this cliff is 52 meters high. We know the initial velocity in y is 0. We know the acceleration in y is that. Well, I've got the distance. So let's go to that formula that has the distance value in it. So we've got the distance, in this case in the y, is equal to the initial velocity in y times the time plus 1/2 at squared. Now we can start putting some numbers into the equation. Well, the initial y velocity was 0, which is great because then it's going to make that term cancel. 1/2, we know the acceleration is negative 9.81 t squared, and we knew the distance was 52. So then when you go and you solve this, you wind up with a time of about 3.3 seconds. So what's the y velocity when the ball hits the ground then? You understand that because it has an acceleration, it's going to speed up. It starts at 0 and it's going to speed up all the way going down. And there's actually a couple different ways that we could solve for that. Do we know the acceleration of the ball? Yeah, it's negative 9.81. Do we know the final? That's what I want to know. Do I know the initial? Because it was started off horizontal and it was 0. Now I know the time. So, and if I work this around, I'm going to get 32. Is it positive or is it negative? Must be the negative because it's moving in what we consider to be the negative direction. So the velocity is going to be negative 32 meters per second. What was the x velocity when it hits the ground? Remember, the x velocity doesn't change because there's no acceleration in the x. So whatever it started off in, the x is whatever it finished. Started off at 18, it finishes at 18 because there is no acceleration in the x dimension of motion. How far does the ball travel in the x direction? Do we know the velocity in the x? Yeah, we know it's the same the whole time. I want to know how far in the x, what we call the range of a projectile. And I now know it was moving for 3.3 seconds. And I do that math, and I'm going to get a distance of about 59 meters. Okay. Now, the final question. I'm back to my diagram here. I normally I'd only draw this once, but I know in my initial setup, I know it's going to go 59 meters when it starts off with a velocity of 18. It's going to do something like this. But let's say we want it to land here at 25 meters. Well, what could I do differently? Well, if I throw the ball faster, it's going to wind up over here. If I throw the ball slower, then it will wind up not covering as much distance in the x before it hits the ground. So the question becomes, well, what velocity do I have to throw it at so that it only goes 25 meters? Well, we know the time to move is still 3.3 seconds. It's still going to take 3.3 seconds to hit the ground because this cliff hasn't gotten, or this building hasn't gotten any shorter. And the acceleration due to gravity is still the same. The ball is still thrown horizontally. So therefore, it's still going to take 3.3 seconds to hit the ground. So I want to know at what speed, velocity, distance, and time, in order to get a distance of 25 meters in the 3.3 seconds, what does the velocity need to be? You can see, kind of rough math, that's going to be 8.23 meters per second. If there was something in this presentation that you did not understand, please ask about it, because we will be moving on to problems where we're moving at an angle and the calculations become a little bit more challenging. So we wanted to see where you were at with this stuff first before we move on.